Good morning. Thank you for joining our session today. My name is Eric Trower, and I'm a member of the marketing team at SICK. For those of you not familiar with us, SICK is the leading provider of sensor solutions. Today, Don DeLash, National Manager for Retail at SICK, will be covering the topic of new auto ID techniques to address product mix challenges. He'll discuss how the optimal application of sensor technology can help ensure higher throughput and fewer bottlenecks in today's distribution and fulfillment centers. A few points before we begin. If you have any questions during the presentation, please type them in the Q&A box in your WebEx control panel found on the right-hand side. And we'll take some time at the end of the presentation to address as many questions as time allows. Lastly, I'd like to mention that following today's presentation, a recording of this webinar will be emailed to each of you, as well as those who registered but may not have been able to attend. At this time, I'd like to turn it over to our presenter, Don DeLash.
Hello, everyone. Good morning, and thanks for joining us today. We really appreciate the opportunity here to talk about, what's going on in our industry and what technologies we have available for you and our customers and the market to continue to deal with the changes that are taking place in our industry. So as Eric said, I'm Don DeLash. I manage our retail team here at SICK. I've been in this industry for about 25 years and also about 10 years in sensing tech and industrial controls. They're some of the industries that I'm most familiar with there. And I graduated from the University of Maryland and LaSalle University, so always a shout out to any Terps or explorers that happen to be in the audience. So we'll get started with our agenda today. We'll look at the new normal. We'll look at some statistics. You guys can probably guess what the new normal is. We're experiencing it in many ways. And then look at what needs that's driving in our industry, what technology exists and is evolving for not only today, but for what's next, and then how to move forward as things continue to evolve in our industries. So the first thing is, and I appreciate everyone. I would much rather be doing this in person and being able to see your faces and see the people and meet people. It's much more comfortable to be in person. But even the UN does video conference calls. I saw this on the news this week. If diplomats from around the world, they look just like us, don't they? But the UN is using Zoom to conduct geopolitical important events. So we can do it too. But everyone is doing this from home or in isolation. So as you have experienced, it's driving e-commerce. It's very easy to get used to that. It's accelerating what's been happening. The graph here on the right is worldwide retail sales, which is now about $6.5 trillion. In the US, it's $4 trillion roughly. And e-commerce is almost a quarter of that, right around 900 billion. And in Q1, the growth is continuing. E-commerce sales in Q1 of 2021 are up 35%. So as I said, e-commerce represents nearly 25% of all retail spend in the US, and it accounted for all the growth in the retail sector in 2020. Pretty much common sense because no one, stores were closed, we were locked down, people were not going out. So it was the first time that ever happened. And the question, of course, is will we go back? The pandemic, the impact has been very imbalanced with e-commerce in general up over 50% in 2020. The graph shows the sales impact of COVID-19, and all e-commerce over 50% growth. Grocery, which made a lot of sense. People were not going to supermarkets, but it is a requirement. It is a staple. So people had to have groceries, and they turned to e-commerce for that. And grocery was up nearly 25% last year. So I think we'll go back. We'll go back to stores. We'll go back to shopping centers. We'll go back to retailers. But I don't think we'll go all the way back. Certainly, some of our changes have been permanent, and I think that's pretty much conventional wisdom that things have changed. And what I want to talk about is how that's impacts our industry and how automatic identification is keeping up with serving the needs of the auto ID material handling marketplace. So what's really happened with the COVID effect is it's really taken what was, we were on a pace to probably over 5 years, move more to e-commerce, and it kind of smushed it into 5 months, really. So I think we were ultimately going to get to where we're at now, but we would have done so much more gradually. And what that's done to our world in the automatic identification and automation and material handling is it's just changed the profile of what we do. Packages have changed. Certainly the volume of packages is increased. The profiles of those packages, what shapes they are, what sizes they are has changed. And the packaging types have changed. Bags, envelopes, soft packs, cartons, multi-packs, etc. And I think auto ID systems really need to adapt to that and provide the not only the performance, but also the communication and the data to keep up with that for you guys and for our customers. So auto ID is there. We're serving this market, but it's evolved, but it has to keep evolving. So the challenges that we're seeing are driving a lot of innovation, and auto ID technology is certainly core to that, and sensing technology overall as well, which we'll get into. Just a note, when I look at these pictures, this one in the upper right, look at all these boxes sitting at this person's front door. You think about not too long ago, that would have been a day at the shopping mall, and now it's a day at the computer, and endless delivery vans coming up and down the driveway. So it's just the way the world has changed, and it's going to continue to change, and we'll adapt to that. In the past, material handling and automation and automatic identification, always a challenge. Unbelievable technologies applied to it. But I think just a few years ago, it was a little bit simpler. Bulk picks for distribution to store, to retail outlet, or to store locations, much easier to plan. Bulk picks, commonality of cartons, single use, good quality. So it was much easier to deal with that. The mix was not nearly as prevalent as it is now. That drove a lot of good foundation for the technology, which we're leveraging today as things change. But to be sure, the product mix has changed. And, why do we care? What does it really mean to us and our customers and to the market? It's really like, because of the package changes, automatic identification systems may be a little less optimal. More no reads, more mishandling, more manual handling required. Really, that's about loss of productivity and lower throughput. Incorrectly routed items. If we don't measure something properly, if we don't track something properly because we get, say, double hits off a shiny package or whatever the case may be, which was an exception maybe 5 years ago. Now it's something that we have to deal with commonly. We can impact how we're delivering to our customers. Damaged goods, we need to be able, with more handling and more variation and more automation, there's an opportunity for damaged goods to be on the increase. So we need to be able to identify that and proactively identify those and handle them in accordance with making sure we keep customer satisfaction up. Inefficiencies, that affects profitability, and that has a domino effect on our businesses. Our service level and our reputation risk. Really, this is about customer satisfaction and making sure that our customers, our end users, folks in their houses that are isolated or working from home or buying from home, get what they want, how they want to get it in a quality way, and when they want to get it. So more variables, basically more variation, means more challenges that we need to adapt to. So really what the automation industry needs and what automatic identification needs to do to keep up is plan for higher throughput, be able to have the capacity to manage higher throughput, faster fulfillment, What does that mean? Denser package spacing on a conveyor, denser package spacing in the footprint of a distribution center or a warehouse. Much greater flexibility, that's very key. And we see that emerging really, really swiftly, is the ability to handle greater package variability and a changing variability. The package profiles and the package variability we have today may be different in a year. So we need to have really flexible solutions. Package types, cartons, bags, tubes, etc. Because of automation, we need our machines to know what they're dealing with. So we can't just read a barcode or say, here's an item that's 12 by 12 by 16. We need to identify what kind of packaging it is so that down the line material automation and down the line robotics know how to handle those packages. Specific indicia like hazmat labels, for example. We need to identify those because we need to know what are we dealing with in our automation? What's coming through our system? What are we shipping? Hazmat's a very common request now. We see more of that than we did a couple of years ago. To know we need to identify specific and special packages like that and handle them accordingly. And then the ability to handle more package data really to feed downstream analytics. And that's sort of the open playing field now that we'll get into in a few minutes. But it's not just handling the package, it's learning about the package and trending the packages and learning as much as we can about these packages so that we can develop and evolve and have flexibility in our automation according to those changes. So that technology today really, when we look at automatic ID specifically, we'll start with laser scanners. Laser scanners have been around for decades. There is and there always will be a place for laser scanners. They perform, the decades of honing the technology and as well as the increasing demands that e-commerce has put on laser scanning and package types and things have provided innovations that really give excellent read performance. They're really good in really high speed applications. They're very flexible, easily configurable, very low cost to operate. They perform really well for high speed, tight spacing applications. So, the foundation of automatic identification for a fixed mount data capture point, laser scanning is a good place to always start and go from there. There is a place for laser scanning in e-commerce and high speed and high density automatic identification. So we always want to see that as part of a consideration for a solution. Getting into imaging technology and vision technology, cameras and imagers, great read performance, very aggressive decoding algorithms and package identification algorithms. They can read 1D and 2D barcodes, which is a good thing. And of course, where they set themselves, where cameras are set apart from lasers is in image and capture and pattern capture. So, the ability to record and archive package data starts with camera technology. Very compact. You can see the size of this camera here. That's a camera that may be used for small package identification, tote identification, very powerful in a small package. Really simple, a lot of times using the same software that we would use in a laser scanner for configuration and for communications. Fit a lot of different applications, fit in a lot of tight spaces, different lensing, different optics for different applications. Mostly what we would see is carton and tote, small carton tote scanning, sortation and conveyor transport. Certainly a lot of use for imaging and image capture and package identification, pattern identification in pick and pack verification, and certainly hand scanning. Years ago, before cameras were prevalent, hand scanning with a laser meant you needed to orient the barcode, etc. Now with a camera, very fast, very easy to capture barcode data and package data under an area camera. High-speed line cameras are really kind of the top of the the food chain as far as imaging goes and automatic identification goes. Really, really superior scanning performance and speed. So high-end applications, very high-speed transportation, sortation, um, uh, really effective for multi-sided scanning, all 6 sides, including the bottom. So a line camera produces a very, very fast series of lines. So we wind up with one image per box or per package, whereas the area cameras are continually snapping 2D images. So we wind up with multiple images per box, and we have to determine which is the best one. So a little bit difference in the approach between line scanners and area cameras. They both have their right place when it comes to automatic identification and automation applications. Um, again, this high-speed imaging and single imaging are really the best way to go for feeding analytic systems and other intelligent warehousing systems. So a lot of value can be pulled out of an image, and these cameras can do a lot more than just barcode reading. They're flexible and adaptable to multiple package types, multiple package sizes. So we really see a lot of use for these increasing. It used to be, the exceptional applications for these cameras, but now we see them really routinely used throughout distribution, throughout warehousing, et cetera, especially now with e-commerce demanding more power out of our automatic ID solutions. Hybrid systems, that's integrated laser and camera systems. So 2D cameras, 1D camera, or line cameras, laser scanning equipment, imaging technology, dimensioning. All those things can be brought together and are commonly brought together to really, really capture everything we can about a package, in addition to reading the barcodes and making sure the package gets identified and sent to the right place. So very common, very flexible. Ultra tight package spacing, high speeds. We often will want to use a hybrid system because of the scan angles that we can get with a laser, reading from the bottom with a line camera, reading from the top with various area barcode readers and/or line cameras ganged together. So there's an infinite number of hybrid systems that we could apply depending on the application that we need over a conveyor. The next form of identification for a package and automatic identification is measurement. So we can read a barcode. We know it's package number 123, but what size is it? Where is it positioned? Is it cuboidal or is it irregular? Is it in a bag? Is it strapped? Is it shiny? So we want to identify these things for sortation intelligence, really, to make sure that our sortation systems are operating as efficiently as possible. Dimension and weight for storage systems, inbound to storage systems, for trailer loading, for shipping, shipping cost, shipping revenue, recovery, shipping cost determination. Again, package positioning is important, and single item verification. So imaging technology is very good at identifying single items, that we don't have packages side by side, that we don't have packages stacked like this. When we put a little bit of intelligence around our automatic identification systems, we can do all these things very quickly and very, very, very accurately. So, ideally with these kind of things, we want to eliminate errors in storage, put away, in our picking, in our sortation, and in our shipping functions. So it all comes back to increased productivity and increased throughput. And when you think back to the original comments about e-commerce and the package variations, and who knows what kind of packaging we're going to come up with next, it's great to have this kind of intelligence and this kind of flexibility built into your systems. When we take automatic identification and some intelligence, where else can we apply it? So master data acquisition, so inbound packages coming into a distribution center, warehouse facility. We want to identify the package, not only what what it is, but how big is the box? Is it the same box we got last time, or did the vendor change their box or change their package? Is it a box? Is it now a soft pack or a shrink wrap pack? Is it a multi-pack? Did it change? So master data acquisition, the top image shows a manual function. We can put a potted plant on that and get a dimensional bounding box for that potted plant, or an automated system where we have conveyors, conveyed items being dimensioned and identified for inbound to a warehouse. So we want to more precisely learn and feed automated storage and retrieval systems, ASRS, whether it's a robotic pickoff or whether this is cross-docking to sortation. We want to make sure that we understand package consistency or changes in the packages and continually update our warehouse systems so that we can notify vendors, we can make sure they're complying, we can update our inventory systems, et cetera. Non-singulated identification, clearly something when package types and variations are coming more and more to our facilities. How do we, if there are bulk scanning and dimensioning systems that are capable of identifying a package and matching its dimension to that barcode, not sorting in the picture you see here, that would be a real mess, but at least feeding into downstream either singulation systems or manual handling for real irregular non-cuboidal type packages. So the technology exists to be able to properly identify, dimension, and feed into downstream systems for these kind of applications. If we get off the package and itself for a moment and go to pallets, with e-commerce driving up, we have high volume items, we have more products being palletized in sort of different ways and inconsistent ways, dimensioning and loading, and also again for depalletizing into automated warehouse systems is important. So scanning a pallet, again, I think the scanning technology and the automatic ID technology is again flexible. Lasers, cameras, imaging systems all apply to pallet scanning. RFID is a great fit. The picture on the lower right shows RFID, what we call a gate system. So non-obstructive, delays to the material handling type system. This image shows a person with a fork truck walking a pallet through an RFID system that's going to read the components and the pallet itself. Think ahead, robotics is increasing, and we're starting to see more and more applications where that's not a person walking this pallet through an RFID system, a gate like that, it's a robot. So, integrating with robots is something we'll touch on in a minute, but that is definitely on the rise as well. And we want to look at pallet integrity too, using dimensioning technology or imaging technology. Do we want a square pallet? Do we want to know if the pallet's irregularly shaped? Can we put a bounding box around that pallet, a virtual bounding box, so that we can make sure that we're cubing our warehouse space or cubing our trailers properly? So this technology is available and it's evolving, and we're seeing, again, going back to e-commerce driven variation, more and more of those kind of applications coming to us. Bin picking, when the products come out of the warehouse, in totes, for example, the use of 3D cameras also on the increase for small item handling, item identification, positioning of product in a tote for a robot, to drive robot positioning for picking and order fulfillment. Tote contents, how do we verify that everything's been picked? There's 11 items in the tote for packaging. The operator misses one at the bottom, a flat or a small package, a ring, for example. The light detection and ranging systems, 3D imaging can detect that tote's not empty and flag it and have the operator come back and properly pack that order. So really some really good applications there and some smart things for automatic ID and integrating into automatic ID systems. Again, multiple technologies here with cameras, imaging systems, even RFID for tote level or for tote evaluation and for high value goods tracking. RFID at a picking station, again, the benefits of RFID is not nearly as subject to ambient conditions, dust and ambient light and line of sight, things like that. Tote content identification, receipt and pick verification is shown in the lower right. RFID is able to do relatively high speed identification, tracking, and multiple code tracking. RFID can provide directional sensing. So when we look at that gate system and we have an operator or a robot moving things in and out of a trailer, we can identify not only the packages, but which direction they were going. Were they coming on or going off? And again, identify operators. If operator's wearing an RFID bracelet or something like that, we can track productivity. We can track who's been loading, who loaded the trailer or unloaded the trailer. Again, most common when we see high value goods like electronics or jewelry. So what's next? Those are kind of things that we're seeing a lot of commonly and really driven by e-commerce. This is a quote I've probably used 10,000 times in my career here. Wayne Gretzky attributed his greatness to his penchant for not skating where the puck is, but where the puck is going to be. And when he got good at that, it made him the great one. Of all the people that ever existed, and you say the great one, and everybody knows who you're talking about, that's unbelievable. And his key to that was anticipation. So where is the puck going in our industry? The answer is data. Industry 4.0, which is sensing and identification technology and network devices and smart devices. It's all about connected devices and analytics, predictive maintenance, deep learning, all these things. Sensing technology and identification technology is the foundation of that. Without sensing, without identification, there is no Industry 4.0. We don't get to cloud-based solutions. We don't get to understanding where our goods are in the supply chain and supply chain efficiencies. So we'll talk about each of these a little bit in a little bit of detail, but really the goal here is to let you know that these are available. This kind of technology is emerging as well, and it's helping drive efficiency and productivity throughout the supply chain, throughout your networks. Deep learning is a buzzword you'll hear along with artificial intelligence. I don't have a PhD in either one. I know they're buzzwords, but with deep learning, what it means in an auto ID environment is we're going to teach our machines to learn very specific conditions, and then we're going to have them make the decisions on those conditions. So look for multiple look for package types, look for carton quality. A system can learn what a good carton looks like and what a damaged carton looks like, and then very, very, with very, very high accuracy, be able to determine a damaged carton from a good carton, even with just slight damage. So things like that are more and more integrating into our automation systems. Robotics, of course, anyone here that was at ProMat DX a month or so ago, it was so heavily weighted towards robotics and intelligence. So robotics is not coming, robotics is here. What it means for automation companies like ours and yours is that we need to integrate and interact with material handling systems and robotics, with automatic ID systems and robotics, sensing technology and robotics, and of course operator safety is paramount to where we're going. And this robotics has moved from the early adopters phase into the mainstream phase, clearly for us. Again, Industry 4.0 is network logistics. So it's really about integrating the device and the communications all the technologies I've already mentioned, barcode dimensioning, RFID, measurement, all of them integrate into Industry 4.0. And I like in the blue box, it's a very sensible way to look at the way things have evolved from mechanical sensors, electromechanical sensors, electronic sensors, and now intelligent sensors. So sensors that know what they're doing, that can make decisions, that can feed downstream processes and have those sensors make decisions. So very, very important that we recognize this is where the puck is going. There is no question about that. Data security, when all this data is flying around, data security and cybersecurity always has to be part of the conversation. SIC sits on the Industrial Data Space Security Association, so we have folks that are involved with coming up with those standards, coming up with making sure that this is part of the solutions that we provide. We have a digital consulting services at SIC. This is something not a lot of companies have, especially in our world of automatic identification and imaging. Our digital consulting services group works with our customers and with our partners to do networking solutions, cloud connection, technology integration, smart warehousing, enterprise systems, and build these deep learning integration systems that I mentioned earlier. Our digital consulting group is very busy, I can tell you that. So this is where the puck is going. Again, back to robotics and what it means. How does it all tie together? Automatic guided vehicles, automated mobile robots, shuttle systems. That's what's driving automation growth in a lot of ways. Autonomous pallet load and unload transport. I showed that picture earlier of the person walking under the RFID gate. We're seeing customers put robots there and look for efficiencies in trailer unload and trailer load with robotics. Package types, when we look at, I mentioned earlier, identifying packages. Is it a soft pack? Is it a carton? Is it an envelope? Our auto ID systems and package intelligence systems will tell a robot to use suction or use a gripper based on what kind of package it is and what the most effective way for a robot to pick that package. This picture at the bottom is a fully automated distribution center with a grid of robots, basically filling orders. High volume, high speed. So even though these are robots, they can move up to 4 meters per second. 50 item orders picked and packed in under 5 minutes. And, large systems commonly doing 65,000 orders per week. So, what we're seeing is really mixed storage and picking applications driven by e-commerce. This happens to be in a grocery industry. Because of the volume increases in grocery distribution, and again, it's a life staple, so it's going to stay, and you see more and more of it. These kind of systems are going to be more and more prevalent. So robotics is all about that package intelligence, the order intelligence, and making sure we have cloud connected solutions that can manage these kind of very, very complex systems. Safety, as I mentioned, is another way. These shuttles and AGVs, AMRs, much more prevalent than just 5 years ago. And SIC, again, another unique group that we have is our safety solutions group. So we have certified safety consultants in our business. We go out, we do assessments, prioritization studies, which means where are the biggest areas where we can improve safety, efficiently and bring efficiencies into our processes in a warehouse. Because it's all about the interactions, again, of people, of automation, of robots, all working together. These assessments wind up with, what can we do to improve safety and improve productivity in distribution centers and warehouses? Where does automatic identification fit in? So we want to make sure through our safety consultancy that everything's integrated and connected, yes, but that there are no weak links in the safety chain. Robots zipping around at 4 meters a second, shuttles coming around the corner, automation, robots moving 2-ton pallets around. It's really, safety has to always be in the conversation. Going back, package analytics is another thing, another portion of intelligence. So imaging systems that can feed package analytics systems very quickly. Shipment verification. Are we getting the right item to the right address at the right time? Archiving images for troubleshooting and trend analysis. Package conditioning, as I said, vendor label compliance. All these things really help us get to system optimization and going back and saying, hey, our system performance has dropped 0.5%. What's happening? Image analytics, package analytics are just by far the most powerful way to do that. Very common and an evolving technology and integrating with as part of Industry 4.0. Deep learning and artificial intelligence, as I said, from package imaging. Really what happens in deep learning specifically is we train artificial neural networks to learn trends from patterns. So the demonstration I saw was mixed nuts. We learn what peanuts look like and what they may look like. We learn what cashews look like. We learn what walnuts look like. You spread them out on a belt and you have the system identify, we don't want macadamias in this mixed nuts bowl. So we identify the macadamias and get them out of there. That's through a process of iterative learning by the machine, and then that real-time decision-making by the machine. Super flexible, and it's something that, again, connects to the cloud, connects to your intelligence systems for your business that you have. Really, really powerful stuff, and this is where the puck is going to be. So moving forward in the new normal, last section here, down the street from where I live, there's a well-known department store chain. It was a go-to place for just about anything we needed in the household. That store closed within the last year, and it's not uncommon, and we just don't like to see that. And I think when we look at how do we avoid that, there's no single answer. There's a lot of business intelligence and acumen and behaviors that come into it, but we don't want that to happen. And from an automatic identification industry point of view, these are the things that are available to us and where the industry is going and how we can avoid that fate. And I think the best companies that we see out there, as I said, are adopting this. It's becoming mainstream. We're transitioning from early adopters into mainstream with these technologies. So the package mix, let's just think about e-commerce. It's changed the package mix forever and probably will continue to change. We'll continue to need to adapt. So really, as users, as integrators, as folks involved with helping customers deal with these challenges and apply the latest technology to do incredible things, just know what we need to do, know about these technologies, know what the challenges you have are with automatic ID and data intelligence, and think about where e-commerce is going. So all these bullets here that I've covered, think about those and just talk to us, talk to your technology partners about all these things. There's a lot of great baseline technology like laser scanning that's been around for a long time that still is part of the solution. There's a lot of great new technology like deep learning algorithms and neural networks that are coming into play now that help us continue to gain efficiencies even with all these variables coming at us. Take advantage of this intelligence in today's auto ID solutions and what we can offer. Industry 4.0 is here. That means network cloud connected devices and maximum visibility across the enterprise, maximum efficiency, flexibility is key. Ask your technology partners, is this a flexible solution? We want to make sure that we're putting in solutions and systems and data systems that are going to be really viable for the foreseeable future and as e-commerce continues to evolve. It's really the foundation of business intelligence, as I said, automatic identification. These things are here now. We want to have that good foundation so that intelligence, automation and automatic identification intelligence can feed these solutions for the coming years. That's what I had to present today. I think we're going to open this up for questions on the chat box. I think Eric might be able to see that. I can't see it. I only see the presentation.
Yes.
But I
Yes.
just want to know if there are any questions. We can handle them now in the few minutes we have.
Yeah, thank you, Don. Just excellent topic and such relevant information for our audience. Yeah, we'd like to take some time for your questions. Just a reminder to those on the call, if you do have a question, on the right-hand side of your screen, there should be a Q&A section, and you can just type your question in there. And Don, we do have just a couple, if you're ready.
Yep.
The first one is, can you explain a bit more about the use of sensor data beyond simply barcode reading?
So I guess meaning collecting the barcode data. So beyond barcode reading to me is some of the things we talked about, like dimensioning of a package type. Is there multiple packs? Are the packages singulated? So when we look at that data, we want to learn from it. We want to learn, are we feeding an artificial intelligence or a neural network algorithm, a deep learning algorithm, to be able to determine changes in the package and changes in the match between the barcode and the package that we have learned? Has it changed? That's one thing. Secondly is we did at SICK, we did our first large scale implementation, live implementation of a cloud connected solution for automatic ID. So what was, and still is, a package sortation system. It's for a sportswear clothing retailer distribution center. It's still sorting boxes, but we have RF tagging in there to help us. It's in some cases high value goods. So we're reading RF tags on some of the containers. We're bundling it with barcode information. We're sending that data to the cloud, and it's helping our customer not only determine where this inventory is that's in motion, either in a warehouse or cross-docking or somewhere in the supply chain, but also anti-counterfeit in this case. As I said, it's high-value goods in some cases. We want to know that if something comes through our distribution center or something is scanned at a retail facility that was not identified or recorded in our distribution center, in our manufacturing facilities, via the cloud intelligence the Cloud Connect, we're using leveraging AWS technology. It's nearly real-time identification of counterfeit goods. So that's an extreme example, answer to a simple question. But I think when you look at sensing technology, all the things we talked about, safety and robotic controls, identifying multiple items in a tote, kind of like this picture shows on the right side of this picture, totes full of multiple things for an order. How do we make sure we're identifying those and that they're tying them to the order, that they're all picked, that they're placed in the right shipping container, et cetera? Really just all important things that our sensing technology is able to do. When I think about tote picking, another very quick example, a camera mounted next to a tote, if an operator reaches into a tote, pulls out an item and puts it in a shipping container, we can not only identify the barcode and read it, whether it's in the tote or as the operator's moving it, but also that the operator did move the product out of the tote. So we're looking for that sort of that motion and that passing of the operator's hand with the product in it from the tote to a shipping container. So, and tying the barcode to that and tying the image to that. So there's so many things that we can do with this kind of intelligence.
Great. Yeah, a few more have come in, Don. The next one is laser reading for barcodes on the way out due to vision sensors, or is it better than vision for certain codes?
It's not on the way out. Vision sensors have imagers have a place. When 2D codes is the most obvious one. Imagers like those line cameras I showed, the big line cameras, like the SICK ICR 980, is super high speed. It's 10 times scanning 10 or 20 times faster than the fastest laser scanners. So super aggressive decoding of damaged codes as well. So in those kind of unique applications, yeah, damaged codes, 2D codes, and when we want to capture images, those three things move us automatically into imaging and camera technology. If we're reading 1D barcodes, a laser has a really good spot, like I said, for simplicity, for ease of use, for low cost of operation, for very high speed, for very tight spaces. In a lot of cases, if we have tight spacing of packages on a conveyor, or even packages on a pallet robot, maybe, whatever the case may be, a laser is able to have a sharper attack angle, so it can see through a little bit tighter spacing if you think about the physics of it. So there are definitely tote reading. If we have a real simple application where we just want to read a tote license plate, or a tray or a tote heading into an ASRS system, and we just need to read a license plate, there's definitely a real place for low cost, small laser scanners. No question about it. I think if we're here 10 years from today, we'll still be talking about laser scanners having a place in automatic identification.
Sure. Yeah, and you touched on this next question a little bit here, but the question is regarding package analytics for auto ID. Can SICK analyze why a code can't be read? In other words, classified between damaged label or partial label or no label, et cetera.
Yeah, to some extent that can be done. There's barcode quality analysis that can be done within imaging technology. So it's a pretty case by case application scenario. But yeah, we can, especially with image analysis and the package analytics functionality I showed. That's really the most powerful way to look at why did these packages reject? Why are we rejecting all these packages from a single vendor? It may be label issues. It may be a pixel is out on a vendor's printer in halfway across the world, but we can determine that when it comes to our system in America and US. So yeah, we can determine reasons for rejection, reasons for not reading through that package analytics that we described. The opportunity is there to apply deep learning to that, to learn what a bad barcode looks like, so that when we have a no read, we can say, why do we no read that? What are the conditions we learned? And say, yeah, that's not a valid barcode, or that's a very damaged barcode. So the intelligence is there. I think that's something that right now we would, as I said, we would consult and say how precise and how deep do we want to be with that to apply the right the right package analytics software to that, solution to that, I should say. Good question.
It looks like we have one last question, Don,
Sure.
And that is, how has the typical service offering changed with the increased use of sensor data in auto ID systems?
Yeah, I think I'll answer it two ways. First of all, up front, when you think of service offering, I think a company like SICK, our service starts the moment we start talking to someone about an issue, about a customer or a user about an issue they're having or a problem they want to solve. So from that point of view, our discussions 20 years ago were about barcodes. 10 years ago, it was about barcodes and data. Today, it's about barcodes and data and intelligence. So this is why SICK has created these safety consultancy teams, the digital services team that we have, because more and more these are part of leading customers in the industry, it's what they're doing and it's what they want to do, and they need partners like us who can help them do that. So on the front end, that service we bring to bear our digital consulting services and our safety consulting services to bear to our customers more and more right at the beginning. On the service side and the installed equipment side, I think what we can look at package analytics. One thing I didn't say was it also supports troubleshooting and remote troubleshooting for our service team. So much of our service, I shouldn't say much of our service, we've enhanced our service by having this ability to utilize things like package analytics, like image archiving, like network solutions, enterprise view of solutions, to be able to troubleshoot and support our customers much more quickly. We also have launched recently a product called SICK Connect, which is basically like FaceTime on steroids a little bit for remote troubleshooting live with our customers or with our own technicians on site. So we certainly see that digital technology and networking technology and package analytics is helping us and our customers troubleshoot and service our equipment. We're never going to replace diagnosing our equipment on site and having trained technicians and technical experts figure out tough, complex problems. But the availability of data to our customers and to our team makes it happen faster and makes it gets more eyes on the problems to help solve problems more quickly.
Right. Well, that was our final question, Don. If you just want to click on to the next slide, I just want to, first of all, thank you, Don. That was fantastic information, and thanks to all of our attendees for joining. And we want to provide you with Don's information here. If you do have any other questions that come up following this call, feel free to reach out. And I also want to highlight.
I just say, sorry to interrupt, Eric, because I know you have one more, but I just want to say thank you to everybody for hanging in on the computer. Not my favorite way to do this. I would much rather be in person. But thank you very much for joining us today. And hopefully we will see you in person on the road real soon. So thank you again to everyone.
Yeah, great. And stay tuned for future webinars. You can see we have one coming up next week, but you can also find any upcoming webinars as well as previous webinars that have been recorded on our website at sick.com. Thanks, everyone. Have a great day.
Thank you to everyone. Take care, everyone. See you down the road.